Hello everyone. Today we'll be covering up the second part of our trigonometry series. In the last lecture we studied that what is trigonometry, what are the basic ratios and all. Right? Now in this lecture we are going to cover the standard ratios of trigonometrical identity, like trigonometrical ratios of standard angles. Like see, in last lecture we studied that what is sine. Can anybody tell me what is sine theta? What is the ratio of sine theta? It is opposite upon hypotenuse, correct? Now, what was the next after sine? It was cos, correct? For cos, it was adjacent upon hypotenuse, correct? Next was tan. We are just revising, okay? So for tan, it's opposite upon adjacent, and remaining things I guess you remember: opposite of sine, then opposite of cos, and then opposite of tan. Not opposite exactly, I mean reciprocal. What is the reciprocal of tan? It is cot. What is the reciprocal of cos? If it is starting with c, then its reciprocal will start with s, and that is sec theta, correct? And same for sine. If it is starting with s, then its reciprocal will start with c, that is cosec theta, correct? I hope you remember all these ratios, correct? So this was the basic part. Now the next part is how we are implementing them in practical things. Okay, so yeah, let's start that. We are still one step away from exactly learning in practical applications, but yeah, we'll learn it. But first we have to know what are the standard ratios. Okay, see what we have done, that we have found out ratios of some standard angles that will give us the same value. Okay, that means for few angles we use them as standard angles. Those are 0 degree, 30 degree, 60 degree, 45 degree, 60 degree and 90 degree. Okay, so for these angles we have made a table for which they are used the most times. Okay, so for these angles we have standardized the ratios, we remember them and we use them for our calculations. Okay, but there's one trick: you don't have to remember all these values. I'll give you a trick that in that you can remember the table. Okay, fine. So we'll start with the how to make that table. So let's start. Just start with writing 0, 1, 2, 3, 4, correct? So let's start with that, and now divide all these divide all these numbers by 4. Okay, got it? Done. After dividing, put them under square root. That's it. Done. 3 steps. Write 0, 1, 2, 3, 4, divide them by 4 and put them under square root signs. Done. Now 0 by 4 is basically 0, and square root of 0 will be 0 only, correct? Now 1 by 4 we can't divide, but what will 1 by 4 give us? 1 by 4 under square root of 1 is 1 and square root of 4 is 2, correct? Now what about 2 by 4? Now 2 by 4 will be 1 by 2, correct? And if 1 by 2 is under square root, then square root of 1 is again 1, but the square root of 2, it's going to be root 2, correct? Now the next thing is 3 by 4. Now square root of 3, again we don't know, so we'll put it as root 3, and for 4, root 4 will be 2, correct? Now the next thing, 4 by 4 is 1 and square root of 1 is 1. It's thoda different that why we are doing it, but just stay with me. You have to do this process. Okay, after doing this, these values we get are all the values of standard ratios for sine theta. That means if somebody gave you sine 0 wala angle, if you have to find out ratio for sine theta, and you know if the angle is 30 degree, then the ratio will always going to be 1 by 2. Okay, that means let's just say if we are talking about a triangle, this triangle, okay, and they have given you theta, this is theta, this is ABC, and they have given you AC is, let's just say 5, and you don't know what is this side? BC. Correct? BC you don't know, but they have given you that the theta is 30 degree. So what will you do? You will do sine 30 is equals to BC upon AC. Correct? Because that is opposite side upon hypotenuse. Correct? So sine 30 will be, sine 30 is going to be what? We know the value from the table, right? It is 1 by 2. So instead of sine 30 we'll replace 1 by 2, and BC we don't know, but AC we know, right? AC we know as 5. So if we cross multiply, we'll get BC as 5 by 2. So this is how we are going to use it. We are going to use this trigonometrical identities. Hope you got the idea. Right? Now first we'll understand how to write the table completely. Now we have just found out the values of sine, right? There are still values of ratios of other 5 ratios, right? So yeah, I'll give you a trick, don't worry. Now I'll erase this. Okay, so sine is done. Next is cos theta. Correct? Now for cos theta, what you have to do? For sine theta you got the values. Now for cos theta, just start the values from the last value, right? That means 1 will be the one first, then second last will be root 3 by 2. Correct? Then this will obviously, okay, this is the middle one, so it will be the same. Then this will be here 1 by 2, and 0 will be here. Correct? So this is the ratio for these are the ratio for cos theta. That means cos 0 will be 1, cos 30 is going to be root 3 by 2. Correct? Now after this, the next ratio is of tan theta. Okay, tan theta is what? Now you remember, tan is sine upon cos. Correct? You remember this, right? Tan is sine upon cos. Now just do that now, because we know sine's value and cos value, we are going to get the same values. So sine 0 upon 1 will be, what is 0 upon 1? 0 upon 1 is going to be 0. Okay, then 1 by 2 upon root 3 by 2. Let's do that. 1 by 2 upon root 3 by 2. Okay, how will you do it? Do you remember what will we do in case of A upon B upon C upon D? Does anybody remember this? Or okay, fine, simple. Just remember that A upon B into D upon C, right? Because what we are doing here, we are dividing A by B by C by D. Correct? So now what we can do, we will write the first ratio as it is, and we'll multiply the divided by wala ratio. Correct? So we get, if we do the same thing here, we'll get 1 by 2 into 2 by root 3. Correct? So 2 gets cancelled and we get 1 by root 3. Correct? So for tan 30 we are getting the standard ratio as 1 by root 3. Clear? Good. Let's try with the 45. Okay, so the thing is 1 by root 2 upon 1 by root 2 we'll have to do, and that is going to be 1 by root 2 upon 1 by root 2. It's going to be the 1, right? Because okay, I'll just write it here and we'll explain it. Okay, so it is 1 by root 2 upon 1 by root 2. Correct? So 1 by root 2 will be 1. Correct? If we do the same thing, multiply by root 2 by 1, so root 2 gets cancelled, 1 gets cancelled, right? So we get 1. Correct? Now the next is for 60, root 3 upon 2 by 1 by 2. Now I'm not going to do it again. Hope you understood it. How am I doing it? But we'll get 2 will get cancelled and we'll just get root 3. Correct? Now the next thing is 1 by 0. Correct? 1 by 0 now. Sine 90 is 1 and cos 90 is 0. So 1 by 0 is going to be infinity. Okay, always remember 1 by 0 is not defined, or you can say infinity, or you can say not defined. Clear? Okay, fine. So now we have to do the remaining ratios, right? Oh, sorry, I erased it. Okay, just a second. Okay, yeah. So now the next thing is cot theta, right? What is the next ratio after tan? It's going to be cot theta, correct? I'll just write here for 0 degree, 30 degree, 45 degree, 60 degrees and 90 degrees, correct? So now for next ratio, what we have to do, there are two methods. Either we can take reciprocal of tan theta, or we can start from the ending. Okay, that means again the same case we did with cos. After writing sine, just start from the end and you will get the cos. After writing tan, start from the end and you will get cot theta, correct? So infinity will be the first, then after that it's going to be root 3, then 1 again, then for 60 it will be 1 by root 3, and for 90 it's going to be 0. Okay, hope you understood till this. If you have any doubt you can ask me, right? So yeah, after cot, the next ratio is going to be the reciprocal of cos, and can anybody tell me? It is sec theta, right? So for sec theta, what's it going to be? So okay, so for sec, simple, take reciprocal of cos. So all the values of cos you can take its reciprocal, right? So it's going to be 1 by reciprocal of 1 is going to be 1 again, then reciprocal of root 3 by 2 will become 2 by root 3, correct? Then after that, reciprocal of 1 by root 2 will become root 2, then the next reciprocal of 1 by 2 will be 2, and now the reciprocal of 0. See, 0 is going to be 0 upon 1. That's what we write, right? If there's no denominator written, we assume it as 1. Now if I take its reciprocal, it's going to be 1 by 0. Now 1 by 0 is not defined, correct? So either we can write not defined or infinity, right? Now cot, sec and cosec theta, right? Now for cosec theta, what's there? For cosec theta, take just the reciprocal of sine. So first is 0, so reciprocal of 0, we just found out it's not defined or infinity, correct? Now for the second, 1 by 2, reciprocal of 1 by 2 is going to be 2, then reciprocal of 1 by root 2 is going to be root 2 only, then reciprocal of root 3 by 2 is going to be 2 by root 3, and the last reciprocal of 1 is going to be 1. Now there's, okay, we did it by taking the reciprocal, but after getting the sec, if we started writing from the end, again we would have got the cosec theta ratios too. Hope you understood this, correct? So this is how we found out the trigonometrical table, sorry, the table for trigonometrical ratios. Okay, now this table is most important. You know, in exam there will be lots questions, different types of questions regarding it. You'll need only 1-2 values out of it, right? But this table is very much important because it will give you free marks. If you know this table, then it will give you free marks in the trigonometry. Okay, so hope you understood this method, and remember that you have to use this method every time you are going to exam. Just after going to exam, just take a pencil. In first 1-2 minutes, if you practice it well enough, within 1 minute you can write the whole trigonometry table, right? And after that, the next all your marks are yours, right? So got it, good, fine. Now let's start with the next thing, like how the questions will be asked based on this trigonometric table. Okay, so fine, let's move ahead. Now let's check how the questions will be asked. There are few basically few rules that you have to remember. See, sine of A plus B. Let's just say if you have to find out sine of 30 degree, not 30 degree, let's say 60 degree. So it's not sine of 30. So let's just say I wrote it as sine of 30 plus 30. It is not equal to sine 30 plus sine 30. Okay, just remember this. It is never equal to sine 30 plus sine 30. Got it? There's one more thing. Like if you see the trigonometric table, the value of sine keeps on increasing from 0 to 90 degree. Correct? And for cos, it's ulta. That means the value will keep on decreasing from 0 to 90 degree. Got it? So yeah, correct. And this same identity, right, like sine, remember this, sine a plus b is not equal to sine of a plus sine of b. Similarly, for the cos we can say the same, that cos of a plus b is not equal to cos a plus cos b. Clear? Now for tan it's the same, and for again if it is written as a minus b, again it is not going to be equal to sine a minus sine b. So remember these things and don't make such silly mistakes. Okay, good, fine. So fine, now let's try some examples. One more thing is there. If it's written sine 30 bracket square, so how do we write it? We write it as sine square of 30, right? And this will mean the value of sine 30. What is the value of sine 30? Can anyone tell me? It's 1 by 2, right? And 1 by 2 square, that is 1 by 4, correct? So remember this. Okay, the value of sine square 30, if it is written sine square 30, then it means 1 by 2 bracket square, correct? Yeah, so let's start with the numerical now. Okay, fine. The first numerical will be, let's say, sine square 30 minus 2 cos cube 60 plus 3 tan raised to 4 45. Okay, so the questions will be asked of this type. Let's say this is a question. Okay, now all you have to do is just put the trigonometric table on one side, right, and start solving it. So what is the value of sine 30? See, sine square 30, I just told you that you can write it like it is supposed to mean like this, right? Then 2 into cos 60 cube plus 3 into tan 45 raised to 4. Now sine 30, we just found out sine 30 is 1 by 2 and to the square minus 2 into cos 60. Now sine 30, if you remember the table, just close your eyes and think about it. 0, 30, 45, 60 and 90, right? Now sine 30 is going to be cos 60, correct? Because we took it as, we started it from the end. Sine 30 is the second row, and from the last, for cos it will be the second last row. So it's going to be again the same, 1 by 2 raised to 3 plus 3 into tan 45 is, what is the value of tan 45? It's 1. Okay, so yeah, next step is 1 by 2 square, that means 1 by 4 minus 2 into 1 by 2 cube, that means 1 by 8 plus 3, and 1 raised to 4 is going to be 1 only, correct? So yeah, 1 by 4 minus, after cancelling this out, we'll get minus 1 by 4 plus 3, correct? 1 by 4 cancelled, and 3 will be the answer. Got it? It's easy, right? If you have the trigonometric table, all you have to do is just put those values from the table in the actual equation. Got it? Good. So this was the first question. Hope you understood it. Fine. Yeah, let's move on to the next question then. Okay, sine 30 minus sine 90 plus 2 cos 0 degree upon tan 30 into tan 60. Okay, so open your trigonometric tables and let's start doing the solution. So for sine 30, what is the value of sine 30? 1 by 2, correct? This is the first step. Minus, so what is sine 90? Sine 90 is 1, okay, plus 2 into cos 0. Now the value of cos 0 is 1, okay. Sine 90 and cos 0 has the same value. Fine. Then now tan 30. What is the value of tan 30? It is 1 by root 3 into value of tan 60 is root 3. Okay. Got it. Then the next step, just do the basic calculations, right? 1 by 2 minus 1 will give you minus 1 by 2 plus 2, right, upon root 3 will get cancelled and in the denominator there will be 1, correct? Now 2 minus 1 and a half, sorry, not 1 and a half, only half, so we'll get 2 minus half and we'll get 4 minus 1 by 2 and we get 3 by 2 as the answer, correct? Understood it? Good. Fine, let's move on to the next thing. Now there are few more identities also. Just along with this, sometimes we use some identities, okay, like I'll write the identities first and then I will give you the idea that how you can remember these identities, because sometimes remembering these many things is not efficient at all. If you know the process, you will never make mistakes in those identities. Okay, so the first identity is sine square theta plus cos square theta is 1. Okay, now how this identity is possible? Okay, for that let's just build a triangle A, B, C, and each and every side I'll give some numbering, like some other name. Side AB I'll call A, BC will call B, and AC will call side C. Okay, now let's just imagine I'm talking about angle C. So for theta, what will be the sine theta for this ratio, for this angle? Sine theta is going to be A by C. Same for cos theta. Cos theta is going to be B by C. Tan theta is going to be A by B. Okay. Cot theta is going to be B by A. Okay. Then sec theta is going to be C by B. And then cosec theta is going to be C by A. Correct? Hope you understood. So yeah, this is done. Now let's just write the sine square theta and cos square theta in terms of these ratios. So sine square theta will be A square by C square plus cos square theta. Now cos square theta is B square by C square equals to 1. Correct? Now let's just say we are multiplying the whole equation by, wait, yeah, right, so wait, so yeah, this is the identity. So we wrote it first, A square, the whole equation by C square. What will happen if I divide it by C square? A square by C square, correct, plus B by C square equals to C square by C square. Now C square by C square will give you the value of 1, right? And now A by C, now just check in this ratio. Now just check these ratios. What is A by C? A by C is sine theta, correct? Sine theta ka square plus B by C. What is B by C? It's going to be cos theta ka square, right? I just replace these values from these ratios, correct? Sine theta is A by C, cos theta is B by C, correct? Now from this I can write my first trigonometrical identity, that is sine square theta plus cos square theta is equals to 1. It's easy, right? Hope you got it. Now this is the first trigonometrical identity. Now there are such more two identities, and for them all we have to do is just change one thing. Okay, I'll erase this for now. Now here, instead of dividing by c square, just divide the whole equation by a square. Okay, just do that. If you divide by a square, it will be b a square upon a, b square upon a equals to c square upon a square, right? So a square plus a square is going to be 1 plus, now b upon a bracket square is what is b upon a? B upon a is cot, correct? So cot square theta, right? And it will give me the value of c square by a square. Now what is c? C by a, cosec theta, correct? So yeah, I get cosec square theta. Got it? Right? So this is our second identity. What was our first identity? Sine square theta plus cos square theta is equals to 1. The second identity is 1 plus cot square theta is equals to cosec square. Yeah? A upon b bracket square will give me, what is a upon b? A upon b is tan. So we'll get tan square theta plus 1 is equals to, what is c upon b? C upon b is sec square theta, correct? So this we get as our third and last identity. Now these identities are very much important because we'll be solving lots and lot of questions by using these identities. Hope you understood till this. Do you have any doubts? Okay, fine. Now let's just solve some questions. Okay. Yeah. Okay. Let's say, see, in trigonometry there are two types of questions. In the first type is you'll directly have to put the values and you'll have to solve the answer, right? And sometimes they'll ask you questions of prove that. Okay, so they'll give you one value at one end, LHS or RHS, and a trigonometrical equation on one end. So you have to find out the values of both the ends and check if they are right, if they are equal or not. Okay, so let's just start with one example. Yeah. Okay, so yeah, now this question is prove that, right? So now we have to prove that left hand side is equal to right hand side. Okay, so now we'll first start with left hand side, that is sine 60 into cos 30 plus cos 60 into sine 30. Okay, now what is the value of sine 60? It's okay, try to remember. See, first row, anyways you can do it very fast. 1 by 2, then 1 by root 2, then root 3 by 2, correct? And in the last 1. So for sine 60 is going to be root 3 by 2. Now cos 30, what is the value of cos 30? It's going to be the same as sine 30, that's going to be root 3 by 2. For cos 60, it's going to be 1 by 2, and sine 30 is also 1 by 2, correct? Now if we multiply this, root 3 into root 3 is 3, correct? And 2 into 2, okay, I'll just write it, and then 1 by 4. So what we got? 3 by 4 plus 1 by 4, and indirectly we got 1 by 4, correct? Sorry, 4 by 4, and that is equal to 1. Got it? Hope this is clear to you. right? So this is how the questions will be asked for class level 9. Okay, now hope you understood the how to draw the trigonometric table, because that is one of the most important part, and still students face problem while remembering the values. So my suggestion is, don't remember the value, remember the process, that how you can make the trigonometric ratios wala table. And in the same way, just remember how to know the trigonometrical identities too. Okay, hope you understand. If you have any doubts, you can ask me in the comments. If you need any suggestion, anyways, you can ask in the comments. Like, share and subscribe our channel to get the third updates about third video. Okay, thank you.